They notice certain patterns and then they prove them mathematically. So the properties of derivatives, if I take a function and I plug it into the limit, if I plug it into the formal definition of a limit, or a derivative, which is where you take the limit of f of x plus h minus f of x all over as h approaches 0, you'll get a certain pattern. And I'm going to try to go through examples 1, 2, 3, and 4 real quick. But the first one is derivative of a constant. So let's say I have y equals 2. Well, that's really the same as f of x equals 2. Okay? Well, now if I go to take derivative of this and I plug that in, every single time f prime of a constant will always equal 0. So the rule is, and you're going to see a bunch of different notations, df dx of a constant, d dx equals 0. So what I'm really saying is that when I go to take the derivative, in other words, if f of x equals 2, well, to find f prime of x, I would need to take the derivative of 2 with respect to x, which will always be 0, always and forever. And the reason for that is there's no x's up here to cancel out. Because I don't have an x to plug in here. I have a number I can plug in here. And so when you, and ultimately you're going to be left with one h term in the top. So when I plug in 0 in the top, I'm going to get 0 times a number. And so it's always going to be 0. So whenever you take the derivative, and we'll find out later when I talk about the power rule again in a little more detail why that is. But when I take the derivative of this, it's always going to be 0. So whenever I say what's the derivative of a constant, you should say 0. Okay? So that's property or rule number 1. Rule number 2 is the one that we use most common. It's the most common rule you'll use in this class for the rest of the school year. And if I say f of x is equal to some constant a times x raised to the n, then f prime is equal to the derivative with respect to x of a times x raised to the n, which is equal to a times n times x raised to the n minus 1. Now in its formal language that looks pretty confusing, but let's just show you what I mean. If I say 7x to the 5th, g prime is 7x to the 5th, then g prime, or I'm sorry, g of x is 7x to the 5th, then g prime will be 7 times 5 times x to the 5 minus 1, which would be 35x to the 4th. Sorry about the handwriting there. Does that make sense to you guys? So let's just try this out and see if you guys are understanding, because I'm talking kind of fast. What would 4x to the 3rd power be if I wanted to find h prime? 12x squared. See, that's pretty easy, right? Now that happens when we go to do that, limit of f of x plus h minus f of x all over h as h approaches 0. That's the pattern. In fact, if I were to take this and plug that into that formula, it would reduce down to this every single time. In fact, that's how they found those rules. Okay? Any questions on that one? So now let's look at problem number, or rule number 3, not problem. So rule number 3 is, if I have a function f of x and I have 5x to the 4th, that's the same as 5 times x to the 4th, where our constant c is 5 and our function really could be x to the 4th, if I wanted to look at it that way. In other words, I could say 5 times f of x is equal to 5x to the 4th, which is equal to 5 times x to the 4th. Now, if that was a function, so what would I do? Well, if I wanted to take the derivative of that, in other words, I could say that g of x is equal to 5 of f of x, which is equal to 5 times x to the 4th, which is equal to 5x to the 4th. And you might say, Mr. Adams, why go through all this extra stuff? It'll serve a purpose later. Just try to get used to looking at it a little differently. So now how do I find g prime? Well, to find g prime, I'm going to leave the 5 alone and take derivative of f with respect to x, which is really going to be 5 times the derivative of d to the x of x to the 4th, which is really 5 times 4x to the 3rd, which is really 20x to the 3rd. Now the shortcut, you could have done that in 2 seconds without writing all that stuff down, right? But later on, we're going to be placed in a situation where we'll have a constant, and we want to take that constant and draw it to the front, especially when we do integrals. So keep that in your keep that in your brain. Okay? That property is real, and we'll practice it now. Now sometimes we could write that differently. I could say that g of x is equal to 5 times u, and I could say that u is equal to x to the 4th, where u represents the function. Okay? Rule number 4, sums. Okay, if I got a f of x is equal to 4x squared minus 3x cubed, I could think of that in terms of g of u plus v is equal to 4x squared minus 3x. Now when I 3x cubed. Now what I'm saying is that my function u is equal to 4x squared, and that my function v is equal to negative 3x cubed. Well, now if I wanted to find out what g prime was, that's not that hard to do. I just need to figure out what the derivative of u with respect to x is, plus or minus, right? I could say plus or minus. And in this case, since I'm using minus, dv dx. Now, Mr. Adams is putting the plus or minus signs in there because I want you to know this rule works the same when I add or subtract. Okay? So I'm just going to change this to plus for now. So then, what is the derivative of this? Well, if I use the power rule, I'll see that du dx is equal to, the derivative of u with respect to x is just going to be 8x. And the derivative of v with respect to x is just going to be negative 9x squared, right? If I use that power rule. Is that right? Yeah. All right. So now, the formality is all the stuff that I've written with g. And what did I figure out? Well, I figured out the derivative of this was 8x minus 9x squared. Well, that's g prime of u plus v. But it's really also f prime of x. Now, most of the time in class, we're going to skip all of this business with G, but we will come to a point where we'll have to separate things using this property or rule. Okay? So for now, we're just going to practice using that rule. Really, what this helps us with is when we go to do the integration. We're going to have a long, complicated problem, and we're going to want to take the antiderivative, and we'll use these properties of derivatives that'll take us from a very large, complicated equation, and we'll break it up into different chunks, and we'll do like derivatives of this and integrals of that, and we'll use these properties to do so. The last one is the product rule, and I wanted to, that's the most important one because I'm going to need to do this, the product and the quotient rule. So now these are important. So I'm going to do the product rule first. So if I say, well, let me just do the example, and then I'll explain the rule to you. Okay? So in our textbook, for example number 4, we are given that f of x is equal to x squared plus 1 and then x cubed plus 3. Well, now this is different. I can't use any of the previous 4 rules to get the product of this. Now I can multiply this out and then take the derivative using the power rule for each term, right? We know if we multiply this out, we'll get like some x to the 5th value and x to the 4th and x to the 2nd. And so we'll get like a crazy polynomial. But that's a lot of work. So what I could do is I could let u equal x squared plus 1. And I could let v equal x cubed plus 3. And so now if I want to find f prime, really what I'm saying is that f of x is equal to u times v. So to find f prime of x, what I really need to do is I really need to write this down as u dv dx plus du dx times v. Or you could think of it like this. This is how Mr. Adams learned it, and I'll write it down this way sometimes. I'll try to stick to the book, but I've always learned it as u v prime plus u prime v. But this is how they write it in the book. Well, what's u prime? Well, u prime, or the derivative of u with respect to x, if I use the power rule, is 2x. Isn't it? Because the derivative of 1 is 0, because whenever we take the derivative of a constant, it's 0. And then the same thing here, the derivative of v with respect to x is just going to be 3x squared by using the power rule, right? Toss the 3 to the front, subtract 1, I get 3x squared. The derivative of 3 is 0, and that's it. So now to find f prime, I'm just going to plug in u, which is the quantity x squared plus 1, times v prime, which is 3x squared, plus u prime, which is going to be 2x, times the quantity v, which is going to be 3x cubed plus 3. Now, I've got to do some expansion, but it is quicker than multiplying this whole thing out and then taking the derivative. So this becomes 3x to the 4th plus 3x squared. This becomes 6x to the 4th plus 6x. I'm going to combine like terms, and I get 9x to the 4th plus 3x squared plus 6x. So that's how I take the derivative using what we call the product rule. Now this one we'll use a lot of. Let me just double check the answer for that one. Oh, you guys, I made a mistake. Did you catch my mistake?
Oh yeah, you put a 3 in front of this.
Yeah, this should have, I was in such a hurry, this should have been just x, so that would make this 2x to the 4th. So this should have been 5x to the 4th. Do you guys see what I did there? I should have written x cubed plus 3, and then 2x times x cubed would have been 2x to the 4th. Then when you combine like terms, it would have been 5x to the 4th. Do you guys see where I made my mistake?
Yeah.
Okay.